In the last lecture we had started the probability part. We learned about the mean, median, and the average value, okay, and the expectation value. In this we'll try to understand a new thing, which is if you take this two graphs, one has this graph, this format, okay, if you have this format and there's some nj, okay, some element, it could be age, it could be anything. In the last example we had taken it to be a age, okay, age of class of student, but in this one I'm taking some random variables, okay. So this is 1, this is 2, this is 3, this is 4, next 5, 6, 7, 8, 9, 10. Okay, so the data is as follows. The data looks like this. You have one box here, one box here, and one box here. Okay, and this is, there are like 8 boxes here. Okay, so let's draw them. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the total data points is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, the other data looks like this. Again nj, this is j. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Alright, and we have the data distributed like this. One box at each interval, and one box between, 2 boxes between 5 and 6. So again there are 10 elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here also 10, but the distribution is different. You can see the mean is same, the average will be same, average, mean, then median is the same. The median in this case is 5, right? And most probable value is also like it's between 5 and 6, right? 5 point, we can say 5.5. So mean, median, as well as most probable, all are same in both the graphs. In this case also, the mean lies at the same point, okay, it will lie at the same point if you calculate it, and the median is also at the same point as this graph, okay. But there's one difference between them, is the spread of data. Here the data is accumulated in this region only, okay, between 4 and 7, but in this case it's spread out throughout the region, okay. So both all these values, the same for both the graphs, same for both the graphs. All right, so we have, but when we look at it, it's different. It looks different because the spread is different. The spread of data is different. So how do we measure this spread? Is there a way to measure this this spread? Yes, we have this spread. Let's talk about an example how to measure this data. Let's say we have this thing, we measure it with respect to the mean value. So how to measure this spread? How to measure this spread of data? Spread of data. Okay, I hope you are making notes and you're following whatever I'm saying, and please make notes and try to just don't watch the video, okay. Do that, pause the pause the video and do some calculations. So let's take some examples of variable. This is some variable x, and whose values are given to be this. This is 9.1, 9.0, and 8.9, and 9.2, 9.3. So these are the values. We have 5 values. Number of values are 5. Okay, and the mean value. If you calculate the mean value, we write mean like this in angular brackets. If you calculate the mean value, okay, so you get 9.1. You just calculate it, you'll get 9.1. Okay, so the thing is, we'll measure this difference. We'll see how much each value differs from the mean value. So in this case, this is x, 9.1 minus the mean value. This is 0. Okay, then you subtract this. This is minus 0.1. This is minus 0.2. This is plus 0.1, and this is plus 0.2. Okay, so you calculate it. This is the x. Actually, I have written small here. This is x, capital X. Okay, so this is what you have. So what if we take this sum of this number? Okay, if we sum them up, we do not get anything, like, because it will give us 0. Okay, because each value differs, whatever the positive difference is from, and then it's equal to the number of negative values here. Like if you have a minus 0.1 here, you'll have a plus 0.1. If you have a minus 0.2, you have a plus 0.2. So it will be distributed so that there will be equal number of positives and negative numbers. Okay, so it gives you 0. So this is not useful. You can talk about absolute values to see the spread, but absolute values are very difficult to work with. So what we do is we take the square of this value and take the mean. Okay, so this is we define as this sigma, this quantity is we define as this mean of this x whole square and mean. Okay, so this is how we define the define variance. Okay, and this is a useful quantity, and this will not be 0. Okay, as in this case we had taken this, and if we take the mean of this value, if we take mean of this value, we would have gotten to be 0. But here it won't be 0, because we have this quantity will be a positive number, and if we take the mean, it won't be 0. It is not equal to 0. But it could be 0 when sigma is 0. Like it could be 0 when all the values, it could be 0 in general. This is in general. It could be 0 when all values are same. When all values are same. Okay, so this quantity is in general not equal to 0, but it could be 0 when all the values are same. Means this is all 9 or 10, all the values are same. Then only you'll get this to be 0. Otherwise, it will never be 0. All right. So we have seen that sigma square is equal to, this is x, or I can write it to be j also, it doesn't matter. Okay, so we take this square and the average of it. Okay, so this quantity we defined it to be, we called it to be variance. Now what we'll do is we'll define a quantity called standard deviation. Okay, and this is simply sigma is equal to root over mean of j minus j whole square. Okay, so this quantity is a standard. This quantity is known as standard deviation, and this one is the square root of the variance. Okay, this is the square root of the variance, and this we'll see that this also gives us a measure of the uncertainty in any quantity, like delta x or delta px. We'll see that uncertainty comes, we in case of uncertainty we calculate using this method. We use this definition in any in calculating any uncertainty in the physical quantities. Okay, so let's simplify this quantity. If we had written, we had learned in the first part of probability video that how can we write this thing. Okay, so what we do is we simply write down, we just replace again, like write like this. This is minus j, this is whole square mean. Now mean, we had defined it to be like this: mean of any function. If you recall it, mean of any function can be written as simply place this function and multiply it by the probability. Okay. Now if you expand this quantity, this would be square, right? We have a square here. This is a definition of mean. All right, so if you square it up, so what do you get? J square minus this is plus mean j whole square minus 2j multiplied by mean. ठीक है, so you get. अब देखो इसमें क्या होगा कि इसको आप मतलब अंदर ले लो. Now open up the this quantity bracket and you write like this. Okay, the first term is j square pj plus summation mean of square of the mean of j multiplied by pj minus 2j j and pj. Okay, so what do you get? You see this quantity is simply what? This is by definition, this is the mean of j square. This quantity is what? This quantity is this. See, mean j is a constant quantity. You will always remember this. This is a constant. It doesn't change with j. This mean is the same value for the whole distribution. It's a constant. Okay, it doesn't change with j. It does not change with j. So the thing is, this summation is over j. All the summations are over j. Sorry, whatever. Yes, all the summations are over j. Okay, so this quantity can be taken out because this is constant for the whole distribution. So this is pj, and this quantity again. See, okay, there was a summation here. I missed it out. There will be summation here. You should write down the summation here. Okay, there is summation here. So if you take down these quantities are constant. So what you have is j pj. Okay, so this is mean of j square plus this is a constant quantity. This quantity is one. If you sum over all the probabilities, this would give you 1, and this one, this is simply mean of j, right? This is by definition simply the mean of j. So what do you get? This is j square plus square of mean minus square of mean, or you can write like this. These two are same thing. Okay, now this will give you minus j square. Now remember this thing, these two are different quantities. This quantity you can write like here. We'll write it. Let's draw a dotted line. So this quantity is different. These two are never equal. These two are different. Okay, so this is different from this quantity. This is square of mean, and this is mean of squares. Okay, mean of the squares. Okay, so these are two different things. Okay, so what we get is sigma square is equal to this is j square minus this is mean square. Now what do we get for the standard deviation? This is j square minus j whole square. So this is the definition which we use to see how much is the spread in the data. Okay, so you should remember this thing. Let's do an example. Okay, let's do an example here. You have this question that two child in a room, there are two child in a room, two children in a room with, okay, two children in a room with age 1 and age 3. Okay, so find j, mean of j square and square of the mean. So if you write down j square mean, so this is simply what? This is 1 square plus 3 square by 2, and this gives you 5, right? And if you take square of the mean, this is simply what? This is 1 plus 3 by 2, and if you take the square of it, you'll get 4. See, these two are different, right? These two are different. So don't get confused. These two are different quantities. One is the square of the mean value, another is the mean of the squares. Okay. So this gives you a measure of how the data is spread. Okay. The lesser the value, the lesser is the spread, the lesser the value of sigma, lesser the value of sigma, the lesser is the spread, and vice versa. The lesser is the spread of data, right? So and vice versa. Okay, so try to derive this this thing by yourself. Okay, I have gone through it. Once you do, you should do it. If you want to understand it, you should do it once by yourself. Okay, this is the point where we started, and this is where we took this to. Okay, so this is a simpler form which we can use, and we'll see that this definition, the standard deviation definition, is used for measuring the uncertainty in any quantity. Okay, so this is important from that point of view. Right.